Yeah, so hello and good afternoon, everyone. Uh, so just a second, we'll be starting. Yeah, so today's class, last class, we talked about matplotlib. We talked about data visualization and plotting using matplotlib. So basically, we had all these different windows, uh, all these different plots that we made. We also did subplots, how we can create multiple plots in a single plot and so on. Then how we can create plots within plots and control access and stuff like that. Finally, we also looked at some different how to save figures, how to make proper labels, legends, and everything. And at the end, changing different things such as line color, line width, and everything. Okay. And yeah, so basically different special types of plots such as scatter plot or a histogram or uh, a box plot. So that's all we talked about. Then we had some questions, practice questions that needs to be solved. So uh, yeah, practice questions that I had given to solve. So basically, we'll be discussing those. So first, what we need to do is we need to import matplotlib, import numpy, and import pandas. Okay. So we are given some data here. Data is basically data drawn from a random distribution. It's 1,000 values. Okay, from a normal distribution. Then we are asked to plot the histogram. So basically, we use plt.hist. We provide the data and we provide the number of bins. Then plt.show will just show you the histogram. Okay. Next, we are asked to add a legend to the figure. So to add legend, what we need to do, instead of just writing plt.hist this much, we need to give it a label. Then we write plt.legend, so which basically shows the legend actually. So this is a legend. So that this is a histogram. Okay. Next question is plot a line plot with multiple lines. So now we have one x value and two y values to denote multiple lines. So this will be a line one, y1 versus x. Line two will be y2 versus x. So we have defined them as numbers and then sine and cos of those numbers. So these will be like sinusoidal waves. Now what we need to do, we need to plot it. So basically we do plt.plot. We provide x and in the first case y is y1. We give it a different color and line style and the label is sine of x. The second one similarly plt.plot x y2 then different color red and dash lines and cos x. Then we add a legend. We want the legend to be at the upper left corner. So we put location equal to upper left. We add the X label and the Y label and we show the plot. So this is how the plot looks like. Basically, we have the label at the upper left corner and all the plots. Right. Multiple line plots. Plot a horizontal bar chart. So basically, we are given labels and values. What we need to do, we need to do plt.bar h. Then we give it the labels and the values. So labels will be your x-axis, values will be your y-axis. So labels will be your y-axis and values will be your x-axis. Yeah, because we want it to be horizontal, not vertical. Right. Next question was plot a scattered plot with different colors and sizes for different points. So basically, we create two different random variables. Then color we are given as basically another random option from 0 to 100. Okay. Size we are modulating. Size also we want to modulate. So basically each point the size should be 1,000 into some random number picked from 0 to 100. Okay. Then we do a plot dot scatter, plt dot scatter, x, y, c is equal to the list of colors, s is the list of sizes, and alpha for transparency. Now you basically have a lot of different points of different color and different sizes. Plot a pie chart with different colors for different slices. Basically, we are again given similar data, labels and sizes. So we have four categories. We put four colors in this list. We do plt.py, basically creates a pie plot, pie chart, sizes, labels. Uh, Sizes will be the different categories. Sorry, labels will be the different categories. Sizes will be the value, numeric value that we want to represent. Colors are colors. And auto PCT basically gives you the percentage, how much uh, formatting it should be, how much formatted it should be. So basically, when we do string formatting, we can do this thing where we do, if we write percentage 1.2f, so it will basically now show us 2 digits after 0. So this in somehow defines the precision and the way in which a point or a number should be displayed on a plot. Okay. Then plot a stacked bar chart. Basically, we have labels and data for men and women. We plot two bar charts. Both of them have labels, and then the different thing is men and women. We have different colors and different labels. We do the plot. It comes like this. Okay. Create two plots with subplots of the series given below. Basically, we are again given the sine cos series. Two plots with subplots. First plot should have horizontally subplots. Second one should have vertical subplots. So now we want horizontal subplots. What we do is plt dot subplot 1 2 1. So this basically create one row, two columns, 1 cross 2 and 1. So this is the first one, the left one. We are putting the sign x here. Then plt dot subplot 1 2 2. So this is basically the right one, and there we're putting the cos wave. Similarly, if you want to vertically stack it, you just need to change the indices. So basically, it will be PL theta subplot 2 1 1. So now basically two rows into one column. So again, in the upper one, we plot the sine, and the lower one, we plot the cos. Okay. Using the file provided, calculate the total sale data for last year for each product and show it using a pie chart. So basically, we are given the data file, mm, company sales data. Let's see first how it looks like. So it's basically month number is given and we are given different products and what was the sale in that given month. And then what are the total units that were sold and what is the total profit. Okay. So what we need to do here is calculate the total sale data for the last year for each product and show it using a pie chart. So we are creating a list of months here first. Then what we'll do, labels, we just choose the labels of those, what do you say, products that we want, not all of the products. Okay, so face cream, face wash, toothpaste, bathing soap, shampoo, and everything. Then in sales data, what uh, we are doing sum of each of these columns. So basically, these are our labels and these should be our values. Then we basically plot these. So labels will be labels and values will be sales data. Okay. Run this code. We see that. If it's, hmm, so we see this basically. So most of the units that were sold were of the bathing soap. Right. Using the same file, read the bathing soap and face wash sales of all months and display using separate subplots in a plot stacked vertically. So basically, read bathing soap and face wash the sale and display using separate subplots in the plot stacked vertically. So basically, we need to create a vertical uh, 2 cross 1 subplot. Okay. Mm, so first we'll run this code, then we'll understand what's happening here. Okay. So here we are reading the data frame. Then we are creating a month list. Then we are creating a list of all the values of bathing soap. Then we are creating a list of all the values of face wash sales. Okay. Then what we are doing, we are creating a figure and array using subplots. We want two plots and we want them to share their x-axis. So this is another way of telling that we want the plots vertically aligned. So basically, they both of them share an x-axis. Okay. Then in the first plot, which is array index 0, we plot this month list and bathing soap. We label it, we color it, and give markers and everything. Then we again set the title as sales data of bathing soap. Then the second one, we do the same for face wash sales data. Okay. Then at the end, we plot the X text. So basically, this is the list of months going from 1 to 12. Then we put the X label and the Y label and we show the plot. Okay. So this is what is happening here. So that was all about matplotlib. In the next module, we'll be learning about again data visualization. So we learn about another library called Seaborn. Seaborn is basically built on top of matplotlib and is also well known for its data visualization and user-friendly API. Okay, so it's also designed to work well with pandas data frames. So it makes it very easy to visualize and explore data quickly and effectively when you are combining packages such as pandas and Seaborn. Okay. The difference between matplotlib and Seaborn would be that uh, Seaborn lets you do certain very difficult things in very easy steps. Okay. So basically, Seaborn makes a well-defined set of hard things easier for us to do. Okay. Uh, Apart from that, uh, yeah. So the pandas thing, Matplotlib was made before pandas. So basically, it does not have a lot of support for pandas. It's not very built in a way or designed in a way to work well with pandas. However, Seaborn is designed as such. Matplotlib's API is very low level, so it's slightly difficult for people to understand who are not that like hardcore into coding and everything and just want a simple plot in a few lines of code. And another thing was that Matplotlib's color and style were at times looked very poor and outdated. So basically, Seaborn fixes all these problems. So by convention, we import Seaborn as SNS, like we do for Matplotlib as PLT and NumPy as NP, Pandas as PD. So this method, SNS.setTheme, will basically set the style of the chart. So you can modify the theme and everything if you want for your plots. And if you define it outside, it will basically do apply the same setting for every plot. Okay, so I just did this to make the plots consistent across the whole Jupyter notebook. Right. So, uh, yeah. Often, when we are doing data visualization, we want to know about the distribution of a variable or the relationship between the distribution of two variables. Okay, so in these cases, what we can do is we can take a look at a histogram, or maybe we can take a look at any way to plot the joint distributions of these two variables. Okay, in Matplotlib, it's relatively straightforward to do that. So basically, here we are generating some random data multivariate data. So basically two variables, X and Y. Mm, we are generating some data. Now what we want these two variables, we want to plot them as a histogram. So what we can do for call in XY. So basically it will iterate over the string. So in the first case, it will be X. In the second time, it will be Y. Okay. What we are doing, plot a histogram of data call. So basically data X or data Y. Density equal to 2. So basically plot the density on the y-axis. frequency basically. Alpha is 0.5. So basically we want them to be slightly transparent, and we get a label, the distribution of X, distribution of Y. Then we have X label and Y label, and we make the plot, and it looks like this. Okay. So it's basically plot points picked from a normal distribution. So basically they're centered around zero and they have a spread and all. Right. So using Seaborn, we can do the same thing. Okay. We can get a slightly visually appealing and smooth estimate of the distribution using kernel density estimation. So it basically estimates the density of your variable. So we can do that by using sns.kde plot. Then we give it the data that we want to plot. Okay, since we want to plot both the columns, we give it the whole set of data. Then we give it a X label. The Y label is always density. So now you see we have these nice smooth curves now instead of those jagged boxes. Right. Uh, we can also do a scatter plot to see how these variables might be varying with regards to each other. So if we do a scatter plot here using sns.scatterplot, we just provide what we want on the x-axis, what we want on the y-axis. These should be columns from your data frame. And then in the data, we provided the data frame. So this is how our variable looks like. It looks like there's some tight binding and there might be a slight positive correlation or something, like if x is increasing, y is also increasing, or if x is decreasing, y is also decreasing. So they moved in the same direction. Right. We can make other beautiful visualizations, which you might need in some cases, such as a contour plot. So basically, uh, sns.kd plot we used here. We just gave it the whole data. So it basically used the columns independently, but now we are defining and that in the data, we want x-axis to be the variable x and y-axis to be the variable y. Now, if we do this, what we get is basically a contour plot, which basically tells you how the density of points varies across the whole area, the 2D area. Right. We can see the joint distribution and the marginal distribution. So marginal distribution is basically the distribution of that variable. So let's say what if we wanted to see this plot, this joint distribution, but we also wanted to see these distributions, these independent distributions together, right? So that is what sns.joint plot does. sns.joint plot, we give it the x-axis, we give it the y-axis, and we give it the data. So we have the joint plot, the basically the joint distribution here. Then here is a distribution of the variable x, and here is a distribution of the variable y. Great. So this is a nice way to visualize, like if there's some relationship between your distribution, between two random variables that you might have in your experiments, or if there is some like and if you want to just check and compare their individual distributions also, it's a good idea to do this. Right. Uh, yeah, the joint plot can even do some automatic kernel density estimation. So basically, it can also estimate density like we did here, similar to this. So what happens is we do a joint plot, we provide the x-axis, the y-axis, and the data. Then we say kind is equal to reg. So basically, the kind should be regression. So there are different kinds we can make a plot, different kinds of plot. The upper one was a scatter plot, which was basically the normal thing. We can also make a KD, a histogram, a hexagon plot, and a regression plot. Okay, so we run this and we see basically it has fitted a line through our data and it has fitted a distribution over each of those independent distributions of X and Y. Okay. So this is a nice way to visualize your variables in your data set. Uh, when you take this idea of a joint plot of like comparing the distribution of two variables, and you take it to like a multivariable thing, where you like generalize it to larger dimensions, more than two dimensions, what we get are called pair plots. These are basically plots of joint distribution between each pair of variables arranged in like a square or something. Okay, so let's for this demo, we'll be taking the iris dataset, which is a very famously used dataset in data science and machine learning. So basically, SNS.load dataset. SNS Seaborn has a lot of demo datasets that we can use for plotting and visualization to try out our visualization. So this is one of them. SNS.load dataset. Then we give it the name iris. Okay, this will load our data into a variable iris. Then, which will be a pandas data frame, and then we do iris.head to see. It has different variables, sepal length, sepal width, petal length, petal width. So these are basically dimensions of different flowers. Okay. And here we are given the species of the flower. Okay. So in this column. Okay. So visualizing these multi-dimensional relationships between all these dimensions, sepal length to uh, sepal width, petal length, petal width, how do they vary? We can use a pair plot to see all those interactions at the same time. So SNS dot pair plot, and we give it the data iris. Hue is basically the variable you want to color everything with. So since we have species as a categorical variable, and we have three species in this case, uh, uh, Setosa virginica and versicolor. So basically, what we do is we want to color all the points that come from Setosa, a single color, all the points that come from virginica, a single color, and all the points that come from versicolor, uh, versicolor, I think. That also different third color. Right. So that's what we are asking as Seaborn to do. So hue is basically color by this column, and height is basically height of the plot. We do this, we run this. It'll take some time in some cases. So basically, if I zoom out a bit, what we have here is a pair plot. So this is each of the variables, sepal length, sepal width, petal width on both the sides, and we have a matrix of plots. Whenever you have the same thing, so sepal length and sepal length here, we are basically shown the distribution of the variable sepal length. Huh. Whenever it's sepal width and sepal width, it shows the distribution of sepal width. But otherwise, it shows the joint plot, joint distribution of sepal width and sepal length. So from here, we can easily see that there's a like probably a very high regression here in petal length and petal width. There's a very strong correlation between these two, probably across different species of flowers. Okay. Similarly for this, which is again petal length, petal width. So it's basically a diagonal matrix, right? These plots and these plots are just basically the same thing rotated. Hmm. So basically, we can identify relationships like this when we look at variables in these kinds of plots. The other thing we can do, like to visualize this thing without creating such a huge plot and a huge with lots of detail, we can create a heat map to see the correlation of different variables. Basically, what we want to do here, we are just selecting the numerical variables, not the species here, because we want to calculate the correlation, and we can only calculate the correlation of numerical variables. So we select the data frame, then we do dot CORR, which will give us the correlation. We provide this value to another function called SNS.heatmap. C bar is basically the color bar, line width is basically width of line. We run this and we see that we get a beautiful plot where if the value is high, if the correlation value is high, the tile is lighter color. If the correlation is negative or low, then it's darker color. Now, if you want to see what the values are, we can do not equal to true. So this will basically annotate all the boxes and give us value of correlation. So any variable will always be maximum correlated with the same variable. So all these diagonals will be one. Then again, it's a diagonal plot because whatever is there on the upper right corner is there on the bottom left corner. because the variables are the same. And minus means they are negatively correlated, plus means they are positively correlated. The value determines what is the strength of the correlation. If it's greater than 60 or 70, it's generally considered to be very correlated. Right. This is how we can visualize different variables. Sometimes the best way to view the data might be via a histogram of a subset. Okay. So basically, let's say you have two categorical variables that you want to see. For example, like time spent on phone and not time spent on phone. For example, like what do you say? Uh, Oh, let's take the example of this data only. So basically, we have a data called tips data in Seaborn. So it's basically data collected from a restaurant where they have like what was the total bill, what was the amount that they tipped, uh, was the person biologically male or female, where the smoker, what day it was, what time it was, lunch, dinner, and everything, and what is the size of the food or something. Okay, size of the order. uh, Something. So what we let's say what we want to do is we want to figure out how many people uh, basically uh, how many people who come at different times of the day uh, give tips depending on whether they are male or female. So basically, we want to compare these two categorical variables, sex and time. Okay, so time has some categories, sex has some categories. What we want to do here is we want to plot the distribution of intersection of each of the values of these categories. So that is something we can do using a facet grid in Seaborn. So basically here we are creating another column called tip percentage, which basically gives us a percentage of tips. But if we do this, we get a tip percentage. So basically, what is the percentage of your tip? Because we can't directly compare the tip. Okay. So then what we do here is grid is equal to SNS dot facet grid. We provide the data set tips. We want rows to be the variable sex. We want column to be the variable time. Okay. And margin may we want titles for these two different things. Then in the grid, so basically this we are creating a grid using different variables. The grid is not yet filled. To fill the grid, we map a function to it, which in this case is a histogram. Plot that histogram. We want to plot the histogram of the tip percentage column. Because histogram you want it for a numerical variable, no? So basically it's the tip percentage that we want to plot. We want to see the distribution of that. Bins are basically for the histogram, how many bins they should have. Now, if we do this, what we get is we get the time on the columns and the sex on the rows. And basically at intersection of each of these levels, lunchtime and meal, what is the distribution of the tips? Dinner time and meal, what is the distribution? Dinner time female, lunchtime female, what's the distribution and all. Okay. It basically gives us some quick insights into the data set if we have categorical variables and we have some numerical predictor or target class. Okay. Mm, so basically, it contains one thing that we can easily see is that the number of points here might be much more than the number of points anywhere else. So basically, the data set contains more data on mail servers during dinner hour than other categories. And typically, the tip amount appears to be 10 to 20% across everywhere, except here, which is over here and here, which it might be slightly more. Right. We can also use categorical plots to make these kinds of visualizations as well. So these allow us to view the distribution of a numerical parameter in an axis defined by another categorical parameter and separated using a third categorical variable if you want. So I'll make this clear when we plot this. I'll just plot it. So basically, we are writing SNS dot cat plot, categorical plot. X-axis, we want the day. Okay. Y-axis, we want the total bill. What was the total bill? We are again using the same data set. And hue is basically, I want to separate this X-axis again based on the sex. So sex is again another categorical variable based on which we are separating the X-axis. Right. Then data, I want the tips data set. And kind is basically box. So we draw a box plot. Hmm. So I set the axis labels. Then what we see here is basically it gives you the categorical variable day across day, how the total will varies, and across sex. So basically in each day, what is the sex of the person that is serving? How is that affecting the total bill? Now, if you were to do the opposite thing, we could have done this also. Now, if you do this, we see the graph for males and females over days, across days. Okay, so we can do things like this. Right. In the following example, we'll be using the planets dataset. So it contains information regarding different planets discovered over the past years, such as what is the method of their discovery, what is their orbital period, mass, etc., etc. Okay. So let's say we want to visualize how many planets were discovered across different years. We can easily do that by using a bar plot where the height of the bar will represent the number of planets discovered in a particular year. We can do that using cat plot. So now we load the dataset planets. What we do, sns.cat plot. X-axis, we want the year. Okay. We want the data is from planets. Aspect is basically aspect ratio XY, or what is the ratio of X to Y, like height to width. And then kind is equal to count. So you want a count plot. So basically, according to each year, it will just count the number of planets that were discovered. And then we just plot it. Okay, tick labels are basically label them every 5 years, basically. So this is the plot. Okay, so we know that most planets were discovered somewhere after 2007, 2009, 10-ish. Right. We can also learn more by looking, let's say we want to get a deeper insight. What we can do is we can look at the method of discovery across years of these planets. So basically here what we are doing, X is year, data is planets, and in the hue we provide method. So earlier like hue we provided here day for sex. Here we want to provide the hue as method for year. And again, the kind of plot is a count plot. So basically across years and across all these different categories, it will show me. Okay, so basically we can see that earlier planet discoveries were mostly based on radial velocity method. But as imaging developed, maybe starting here, and here, more people were able to see planets by imaging. And then other methods might have developed later. So these methods such as this one, which is probably transit, is something that has helped us discover a lot of planets. But probably it came somewhere around 2004 or something. It was not there before. So these kinds of things we can get from the data if we make plots like this. For more information, you can always go to the Seaborn documentation, and you should, of course, see the example gallery that they have. I'll just share my screen and just check what I'm sharing. Mm, Okay, yeah. So basically, the example has a lot of different kinds of plots and how you can make them. So basically, if you want your data represented somewhere, some way, you just go to one of these plots. Then you basically look at the code and you can figure out the comments and everything. For different plots, you can. So this is basically what the hex plot looks like when you do a joint plot in SNS. If you choose hex, it gives you a plot like this instead of dots or points. Okay. So yeah, you should visit that and check it out. Now what we will do is uh, we'll we learned about data visualization. using Matplotlib, how we can make plots using Matplotlib. We learned about how we can use make plots using Seaborn. So now what we want to do is we want to do a demo. So basically, we don't want to do a demo. So basically, this is like a demo data set for us to explore. And now we'll know actually what we are supposed to do in data visualization. Okay. So let's say you are given just a data set. For example, we are given this data set. Okay, this empty cars data set. So this data set consists of data that is extracted from the 1974 uh, Motor Trend US magazine. Okay, and comprises of a lot of different things such as fuel consumption and 10 different aspects of automobile design and performance for 32 automobiles that were released in that year and the previous year. Okay. So basically what we are doing here, we are just importing everything that we think we might need. We are importing NumPy, pandas, of course, to handle the data. Then we are importing Seaborn and Matplotlib so that we can make the plots. Uh, what we are doing next, we are reading the data frame, data set. So basically it's a CSV file. I'll be providing you in this email. So we'll do pd.read CSV, emptycars.csv. Then we have this data set. We just look at the head. So basically it will give us what the data set looks like. Model, MPG, cylinder, disp, HP, that and everything is there. So basically all these different variables means are and things. Model is basically the model of the vehicle. MPG is miles per gallon, which is basically a measure of mileage. Cylinder is basically how many cylinders it has. Disp is basically what is the displacement of the engine in cubic inches. HP is the gross horsepower. DRAT is the rear axle ratio. Weight is the weight of the vehicle. Cusack is like how much time it takes for it to cover quarter miles. BS is basically the type of the engine. Is it V-shaped or is it straight? Okay. AM is basically what is the transmission? Is it manual or is it automatic? Gear is basically how many maximum gears it has, three, four, or five, or six. Then carb is basically the number of carburetors that a car has. Okay. So since the model column is supposed to be different because all these cars are different, what we can do is we can index our data set using the model column. So basically we do empty cars.setIndex. We give it the column name model and we write in place is equal to true because we want to modify the data frame. And then we see the data frame again. So this is how it looks like now. We have all these different variables, numerical variables, and we have the model on the uh, index. Okay. We can use the info function to get more information about the different columns in the data set. So we didn't see the full data set, but to get more information, we can see the info. So basically, it tells us what all the column names are, how many basically values are there, how many null values are there. So in all of the cases, we have 32 non-null values. So basically, our thing should have 32 rows. Okay, so 32 data points, and the data type is basically integer or float. Okay, integer or decimal point. To confirm that it has 32 rows, what we can do is empty cars.shape give us that it has 32 rows and 11 columns. 11 columns is these columns. The model we are actually using as the index. Okay. Yeah. So we have a lot of variables and there can be so many interesting relationships that we can try visualize or try to figure out. So first of all, the most basic thing that we can do is we can use a count plot to see if there is a certain trend in the cars produced. Like, do most cars have six cylinders or do they have this many carburetors or something? So what we do is SNS.count plot, and in the x-axis we provide the cylinder, number of cylinders, and we provide the data set empty cars. So what it does is it will just give the count of how many rows have cylinder as 4, how many rows have cylinder as 6, how many rows have cylinder as 8. Okay, just a second. Hi. So sorry, guys. Yeah. Yeah. So this is basically gives us the count of these different categories. We can again do the same for the carburetors. So SNS dot count plot y is equal to carburetor, data is empty cars. Then we see. Notice that the plot is turned. Okay. So here we defined X as cylinders. So basically, cylinders was on the X-axis and count was on the Y-axis. Now we are defining Y as carburetors. So basically, Y will be carburetors will be number of carburetors will be on the Y-axis and count will be on the X-axis. Sometimes it's easier to visualize plots like this. Sometimes it's easier to visualize plots like the other way. So depending on your use case, you can use any of these things, right? We can visualize each independent variable like this, but what if we want to visualize uh, like proportion of different variables and like how they are, like how two variables interact, basically. Okay, if there are like categorical variables, kind of, then like for example, uh, basically categorical or discrete variables. So basically, let's say we want to answer the question, if cars with four gears are more likely to have four cylinders or six cylinders or eight cylinders, what is the answer? So then we can do a count plot again, and x-axis will provide gear. Okay, and the hue we provide cylinder, which is our second variable. Basically, what it does is the x-axis is gear, we are on the y-axis is always the counts. Q is basically in the gear, it will provide divided into three different uh, columns basically for each cylinder, each value that we have for cylinder. Okay. These kinds of plots work well for categorical variables or discrete variables where there are not a lot of different variables. But these won't work well when you have a uh, what do you say, numeric kind of variable, very number heavy, then these bars and plots become very difficult. So that's when you shift to histograms and all. Right. So basically, we can look at the histogram for a numeric variable, which would be the better thing to do here. So what we do is SNS dot his plot, which makes a histogram plot. Then we are just giving the variable empty car dot mpg. Mpg is basically the mileage. We want 10 bins and we want the plot to be in green. No, we want it to be in blue. Okay. So we do this and this is how it looks. So of course, mileage is a very interesting variable. So we wanted to look at that because everything is about money after all. And mileage is basically how much money you'll feed to the vehicle. So looking at this variable, we can see that like most cars that were released in these years had a mileage of around 17 miles per gallon, but some of them did exceptionally well and had a mileage of around 35 or so. Huh. This is just one variable, but what if you want to look at how this variable changes with respect to other variables? So that's also another thing that we might be wanting to look at in a data set, right? So for example, which we want to figure out if the number of cylinders affects the mileage of a vehicle. It seems like a very reasonable guess, but we should, to be sure about it, we can visualize it, right? Not to be sure, but to at least see a trend. So what we do is SNS dot scatter plot. Data we give it as empty car. On the x-axis we have cylinders. On the y-axis we have uh, miles per gallon, which is basically the mileage, right? We get plots like this. Remember, we get plots like this because cylinder has just three step values, 4, 6, and 8. So many of the rows have 4, many of the rows have 6, many of the rows have 8. Whatever the case is, we see that there is some evidence of a like decreasing term in general. So basically, if you have more cylinders, you are more likely to lose out on mileage, which makes sense. Okay. But since the x-axis is discrete, as I said before, the points above are lining up and we are not able to see exactly like what is happening, what are the points above. So basically what we can do in this case is we can visualize this whole thing better if you just make box plots of these variables. So we get the distribution of these individual variables. So how can we do that? We basically copy the exact same thing that was here. Okay. till here, and we add an extra argument called kind is equal to box. So it will know to make a box plot. Now we can clearly see that basically if you have less number of cylinders, your mileage is quite high. And the distribution seems to have very little overlap across these different cylinder classes. So maybe cylinder is a variable that can be used to strongly predict the value of mileage of a vehicle. Right. So these are the kinds of things you come up with when you do data visualization. So basically, randomly, we are just looking at different variables. We are trying to like reasonably because we have some hunches. We are trying to see, okay, maybe I suspected that there's a relationship between the mileage and the number of cylinders, and I want to plot it. And when I plot it, I see that okay, that thing is there. So that kind of validates my feeling and then makes it sure that if I want to use this data, for example, to see to predict if like other cars were released at that time with these different features, what would their mileage be? Things like that. If I want to predict the mileage based on the number of cylinders or other different variables, this is data visualization is the first step where you see if there is any relationship between different variables. Okay. Now we see the relationship between two more variables. We want to check if transmission affects mileage. So basically, manual transmission is when you are shifting the gears, and automatic is when the car is shifting. People would assume that they shift better. That's why they get a manual car, but that might not be the case. Let's find out. So what we are doing here is sns.cat plot. Okay. Notice, yeah, it's the same thing. Okay, we give it the x-axis, transmission, the y-axis, the mileage, then data is empty cards data, and then kind is box. We want a box plot. So we see the plot like this. So 0 is basically our automatic, 1 is basically manual. So basically, automatic vehicles have lower mileage compared to manual vehicles. So people were right, I guess, but this variable might not be as strongly related because you see there's a huge overlap between these two distributions. Whereas in this case, there was a very narrow overlap, you can say, between all these different variables, all these different box plots, right? Here, there's a huge overlap. So these are also the kind of things that you look for when you are doing data visualization and stuff. You want to see if there's a relationship and like if you feel like there's a significant enough relationship or not, because in this data set we just have 11 variables, but sometimes you will have like a lot of variables. Okay, in that case, going through them one by one and looking for relationship between each variable is a very tiring thing to do. So what we do is we generally use a pair plot, like I talked about in Seaborn. So sns.pairplot, and we give it empty cars. Now, if we run this, it'll basically create a pair plot. It will take some time because it's plotting a lot of different variables, as you can see. Even with 11 variables, it's not that easy. So imagine if you have like more than that. So this is a behemoth of a graph. Even if I zoom out twice or thrice, I can't cover it in my whole screen. So basically, it's showing every variable plotted against every other variable, and we are getting the distribution of each variable. Now, this is a very hectic plot to look at and figure out something. So what we'll do is we'll use a heat map to simplify it to see what is the really, is there any relationship between different variables. So what we do is we do sns.heatmap. In the first, we have to provide it a correlation value, correlation table. So that we do by empty cars dot corr, the correlation function we call. C bar is basically color bar we want for reference. Line width is basically length, width of the line, and annotate is equal to true basically means that we are annotating the data. The each of these boxes is numbered according to their correlation, right? We do this, we see that, so the variable we were interested in, of course, the diagonals are all one because these variables are super correlated with themselves. Lighter colored are more correlated and darker colored are less correlated, uh, positively, negatively, respectively. So we want to see mileage. Now we see mileage is negatively correlated to this variable, number of cylinders. to the displacement and the HP horsepower. In some way, these three variables are also very similar. For example, cylinder is almost 90% correlated with displacement. Of course, if you have more number of cylinders, you have more displacement, engine displacement, right? Then cylinder to handle that. And cylinder and HP is also correlated because, of course, more horsepower, better cylinders, more horsepower, and everything. So we'll just take one of these variables. We'll take the number of cylinders, I think. The displacement will take cylinders we saw above. Then we'll plot the mileage against the weight because this is also very negatively correlated, right? And this is only moderately correlated with the other variable. Then another relationship we should look at is mileage and drat. Okay, drat is basically I forgot. Let's just check. Yeah, rear axle ratio. Okay, the axle ratio of the rear axle. Uh, okay, so now what we'll do is we'll just take these variables because they have piqued our interest because we are interested in the mileage. So what we'll do is we'll do scatter plot of these variables versus the mileage. Basically, drat versus mileage. We provide x is equal to drat, y is equal to mpg, which is mileage, and data is empty cars. We get a scatter plot like this. Then we do the same thing for displacement. We get a negative because it was negatively correlated, and we do the same for weight, and we see that this is also negatively correlated. Okay. So since now we have two, three variables and we know more or less that these are independent of each other or they're not really that correlated. So what we can do next is we can think about doing regressions or building machine learning model using these variables to predict the mileage of another car that was released at the same time with these features and everything. So those kinds of things we can look at next. Uh, so basically, that's what we'll do when we'll go to the next module, which is scikit learn, and we'll learn about the concept of machine learning and data science, a little bit of that. So probably a theory class or a presentation or something might be coming up, followed by a session where we code everything. Okay. So as a teaser, we have just given a simple visualization. So using Seaborn, you can actually fit a linear model in a graph. So you do this by LM plot. Okay. We again, as simple as it is to use every other function in C1, it's as simple. You give it what the x-axis should be, weight, the y-axis should be miles per gallon, the mileage, and the data is empty cars. Now, if we run this, we get the plot like before. So weight and MPG, we get the same plot here, but now we have a regression line along with the confidence interval here. Okay, so basically the goal of data visualization would be to um, look at some raw data, plot it, visualize it. Then after you visualize it, you decide like if you feel like some variables are related to each other, some variables are correlated, some variables seem like they seem to share a relationship, whether it be positive or negative. And then looking at these relationships, looking at these different plots and statistics, you can think about doing statistics on the different things. So if you're a statistician or a mathematician using these plots, what the next thing that you'll do is have statistical tests. Okay. So for example, if we, um, let's say we go to the example here before, some plot we had, right? These distributions. So a mathematician might be more interested in knowing if these distributions are different distributions or the same distribution. So they might do a t-test or a f-test or something like that to check if the variance and the mean of the distributions are the same and everything, right? But for data science people and people like us, what we need to do is, in general, we need to build a model that predicts something or build a model that can cluster something or like give you some information. Okay. So some predictive model in most cases. So basically, we want to predict the mileage here. So you do a regression basically on different variables, or we will build a linear model, or we build another kind of model. Different kinds of machine learning algorithms we can use to build models so that given other variables, values of other variables, we can easily predict what a mileage of the car should be if it was released in 1974. Okay. So that's it. That's the goal of data visualization. That's how we should do it. So this was just one example. We'll take a look at a, sample project at the end of the course. So during that sample project, what will happen is we will basically go through this whole data visualization process in detail, where we'll basically again, so the same thing again. So basically, we'll be given a data set and we'll be given a question and we are trying to basically figure out what happens or how to deal with the question, and we try to visualize data in different ways so that we get at it, right? So after today's class, you are given basically this Titanic data set, which contains if people on the Titanic survived or not. So did they survive 1 or 0? Then what was the pay class? Whether they were male or female? What were their age? And other different variables. How much fare they paid? Which class they got in? Uh, okay, and whether are they still alive or not? Whether alone or not, and stuff like that. Okay, so all you're asked to do is you're given a bunch of plots and you're asked to recreate those plots. So the best thing to do here would be there are just 5 plots, so it's a very easy thing to do. I would want you to like go to websites such as Kaggle or something where you can get hold of more data sets. And then what you can do is you can use those data sets to visualize different variables and stuff like that. Right. Develop an act for it. Like go for it. Just do it and like uh, figure out. Let's say you have these kinds of variables. What is the best way to visualize it? What might be good? What relations can we do you think can we find and stuff like that. Right. So that's something you should definitely do. But now, for now, a hint here would be like to look closely at the axis, what is on the x-axis, what is on the y-axis. Of course, the data set is Titanic. You can look at the data set. You can get info of the data set, summary and everything. That might also help you. Then you look at the variables and you see the type of plot, and that should be enough to tell you what kind of plot you should make or how you should make it. Right. So this is the homework that you need to do. Uh, I'll be attaching this file to the email also, so you can go through that. Uh, Next class we'll meet and we'll talk about scikit-learn, scalar, and how actually we do probably the principles of machine learning and data science. What are the different kinds of machine learning and what is the general process of doing machine learning, practicing machine learning, right? So we'll probably have shorter classes, okay? Because in each class I want to cover a separate topic, but in depth. So, and we'll probably have classes every week instead of 2 classes 1 week. We'll just have one class. So Thursdays, probably. This Friday we don't have a class. I'm not sure about next Friday. So yeah, we'll talk about that. Uh, Anyways, I'll see you next week on Thursday. Thank you for joining in and good luck on the exercises. Bye.